In this video, we're going to look at the SUVAT equations when we have acceleration due to gravity. On Earth, any object is going to accelerate towards the center of the Earth as a result of gravity, because of gravity. And if we ignore air resistance, we can say that that rate of acceleration is going to be g, and g is equal to 9.8 meters per second squared. So if we ignore air resistance, which is what we're going to do in all of these questions, we're going to say that any object is going to accelerate towards the center of the Earth at a rate of 9.8 meters per second because of gravity. So here's a question. A particle is projected vertically upwards from a point O at a speed of 15 meters per second. So we're projecting our particle upwards at 15 meters per second. We're going to call that a positive 15 meters per second. So we're going to say U is a positive 15, and G is going to be acting down. So it's not going to keep getting faster and faster and faster going up. It's going to slow down. So we're going to say acceleration is negative 9.8, negative g. So we're going to say anything going up is positive, anything going down is negative. So the initial speed is positive 15, but the acceleration is negative g, because the initial speed is up and the acceleration is down. Find the greatest height of the particle. So find the greatest height of the particle. So it's going to move up till it reaches its maximum height, and then it's going to come back down towards Earth. At its maximum height, we can say its velocity is 0, because it's starting at 15. It's going to get slower and slower and slower and slower because of gravity, and then it's going to have negative velocity on the way down. So at the point where it's at its maximum height, v is going to be 0. It won't be moving up any further, and it's not yet moving down. For that split second, its velocity is nothing. So here's our information. We need our SUVAT equation without t in it. So which equation is that? And that is v squared equals u squared plus 2as. So substituting in, v is 0, so 0 squared is 0, equals u squared, 15 squared, plus 2 times negative g times s. 0 equals 225 minus 2g s. If we plus 2g s to both sides, 2g s equals 225. So s is 225 over 2g meters. That's our exact answer. We could type it into the calculator. So if we did that, 225 over 2 9.8s, that gives us 11.4795918 and so on. But we can't give an answer to that degree of accuracy because we've used an approximation for g. So if we give our answer to two significant figures, we're going to get distance of 11 meters to 2sf. Find the time taken for the particle to return to O, to return to where it started. So the particle's gone up, reached its maximum height of about 11 meters, and returned to where it started. So there's two ways of doing this. We can either split the motion, so just work out the time taken to get to the top, and then double it. So if we do that, we'll have u as 15, v as 0, a as negative g, and we will work out the time. There's another way of doing it, which is usually the more complicated way, and that is to do the whole motion in one go. So that will be where s, displacement, is 0. So because it started at O and it's finished at O, it's moved nowhere. It's got no displacement. So in that case, u would be 15. A would still be negative g, and we would work out the time. We could use either of these two methods, and we should get the same answer. If we use the first method, the red method, we're going to have to double the answer, because we're just working out the time to the top, and then we'd have to double it to work out the time back down. With this method, the answer we get out for t will be the answer. So for this method, we need the equation without s in it, which is v equals u plus at. So we've got 0 equals 15 plus minus g times t. 0 equals 15 minus gt. gt equals 15. So t is 15 over g. And of course we've got to double it. So answer times 2 is 30 over g seconds. And again, we could type it into the calculator, 30 over 9.8, and give our answer to two significant figures, which is 3.1 seconds. And with this method, we need the equation without v-ing it. So that's s equals ut plus half at squared. So 0 equals 15t plus half negative gt squared. Simplify it, so 15t minus half gt squared. So we're going to have to solve it by factorizing into one bracket. So we've got t 15 minus half gt. So we say either t equals 0, which displacement was 0 at the start, or 15 minus half gt equals 0. So 15 equals half gt. Double both sides and divide by g, and we get the same answer. So you can see we get the same answer by doing both methods. The quicker method is usually to split up the motion and double the answer. So split up the motion into small parts is usually quicker than doing one motion for the whole journey. A particle is dropped from a height of 4 meters above the floor. Find the time it takes for the particle to reach the floor. So SUVAT, it's dropped from 4 meters above the floor. So it's dropped from here and it's going to go down to the floor. So there's the motion, a downwards motion. So its displacement, it goes down 4. So if we say down is negative, its displacement is negative 4. It's dropped, so its initial velocity is 0. Its acceleration is minus g, minus 9.8, and we're working out t. So the equation without v in it is s equals ut plus half at squared. So substituting in, we get negative 4 equals, well, 0 times t is 0, plus half negative g t squared. So negative 4 equals negative half g t squared. If we multiply both sides by negative 2, we would get 8 equals gt squared. Divide by g. 8 over g equals t squared, and square root t equals the square root of 8 over g seconds. If we type that into the calculator, square root of 8 over g, 8 over 9.8, we get t equals 0.90 to 2 significant figures. Again, not giving our answer to a great degree of accuracy because we're using an approximation for g. Find the speed at which the particle hits the floor. So find v now. All the rest of the information is the same. So if we hadn't worked out t, we would use the equation without t in it, which is v squared equals u squared plus 2as. V squared equals 0 squared plus 2 times negative g times negative 4. So v squared equals 8g, and v is the square root of 8g meters per second. So the square root of 8 times 9.8 to 2 significant figures, 8.9 meters per second. Okay, here's another question. Try and pause the video, give it a go, see if you can do the question. If you get stuck, or if you're ready to go through the answer, just press play. So a particle is projected vertically upwards with a speed u. The greatest height reached is 50. Find the value of u. So what do we know? We know it's gone up 50, so displacement is positive 50. We're working out u. At the maximum height, so the greatest height, v is 0, and a is negative g. So we want the equation without t in it. So v squared equals u squared plus 2as. So substituting in, we've got 0 equals u squared plus 2 times negative g times 50. So 0 equals u squared minus 100g. So 100g equals u squared, which means u is the square root of 100g. And we can type that into the calculator, square root of 100 times 9.8, and to 2 significant figures, we get 31, and it's meters per second to 2sf. Find the time for which the particle is 40 meters or more from O. So we projected it up. It reached a maximum height of 50. So it reached 50 up here. So the time it's 40, so if this is 40, the time it's 40 and above is this time here. So there are different ways of answering this. The quickest one will be to work out that motion there between the 40 and 50 to the greatest height. So in that time, in that motion, it goes up 10. So displacement is 10. We don't know u, but when it's at the greatest height, v is 0. the a is minus g still, and we want to work out the time. So if we work out that time, then we will double the answer. That will be the quickest method. If you wanted to do it in one motion, you could by having s as 40 from the start. So u would be the u we worked out in the previous question. V we wouldn't know because you wouldn't know the velocity at 40. A is still negative g, and we would work out the time. This method is going to be a lot easier. This is the one we'll use. You could use this method. It would result in using the quadratic formula. So it will be a lot longer. And we're using our answer from the previous question, which if we can avoid, we should. So the method of choice, the preferred method, would be the green one. So which equation doesn't have u in it? That's s equals vt minus a half at squared. Substituting what we know, so 10 equals 0 times t, which is 0, minus half times negative g t squared. So 10 equals half gt squared, times both sides by 2, 20 equals gt squared, divide by g, so 20 over g equals t squared, so t is the square root of 20 over g. We of course need to double this answer because that's just up to the top. So double the answer will give us the total time over 40. So root 20 over g times 2, so two significant figures, is 2.9 seconds to SF. Okay, another question. A particle is projected vertically upwards from a point 4 meters above the ground. So it's projected, so the ground's down here. It's projected from 4 meters above the ground with a speed of 18. And it can come back down. So what do we know? The initial velocity is 18. We want to know the total time of the flight. So the total time of the flight, well, we can say s is going to be negative 4, because from its initial point, at the end of the flight, it's gone down 4. So if we're going to do it in one motion, we're going to say s is negative 4. If we wanted, we could work out the time to the top and then the time down afterwards. But that would mean doing multiple workings out. So this will probably be the easiest way. A is negative g, and we need to work out t. So the equation without v in it is s equals ut plus half at squared. So we've got negative 4 equals 18t plus half negative g t squared. So we are going to have a quadratic, which isn't too bad, I hope. So negative 4 equals 18t minus, if we change g to 9.8, half of 9.8, so 4.9 t squared. So we're going to need more room. So if we take everything over to the left side, we've got 4.9 t squared minus 18t minus 4 equals 0. So we use the quadratic formula. So a is 4.9, B is negative 18, C is negative 4, and we'll substitute in, so T equals negative 18 minus negative 18 plus or minus the square root of negative 18 squared minus 4 times 4.9 times negative 4 all over 2 4.9s. So we just type it into the calculator and we'll see what we get out. So we get out 3.9 seconds, and I'm guessing the other answer will be negative, or negative 0.21 seconds. We can't have the negative time, so the answer is 3.9 seconds. Hopefully, if you did it in 2 stages, so you worked out the time to the top, but then the time back down, you would have got the same answer. Find the total distance travelled until it reaches the ground. So the total distance travelled is going to be the distance to the top and then the distance all the way down. If we work out, we know that U is 18. So if we work out the distance until it gets to its maximum height, then we would work out this red distance, and then S plus 4 doubled, nope, 2 S's on 1 4 would be the total distance travelled, because it didn't travel the first 4 meters. So it'll go S, then S, and then 4. So if we work out this S, we'll have 2 of those plus 4 meters, and that will be the total distance travelled. So which equation doesn't have T in it? That's V squared equals U squared plus 2AS. So we've got 0 squared equals 18 squared plus 2 times negative G times S. So 0 equals 18 squared, which is 324, minus 2GS. So 2GS equals 324. So S equals 324 over 2G. That's S. We're going to double it and then plus 4. So we're going to times our answer by 2. Then plus 4. So 2 S's plus 4. And that gives us, to 2 significant figures, 37 meters.